You tell me.
2 o'clock?
Sure. Okay, so the hands of the clock are at 2 o'clock. So there's 12. There's 2. I want to know, and I'll tell you the diameter of the clock is, I don't know, 8 inches. Find the length of the arc that's formed as those hands are at 12 and 2. Okay, so that's the question that's being asked right now. If the time is 2 o'clock, what is the length of the arc formed between the minor arc? Okay, I'll say the minor arc here because I could be talking about the other arc from 12 to 2, but I'm going to be talking about the minor arc. All right, so I have those formulas. I have length of an arc equals measure over 360 times pi d. Or I could use theta equals S over R, but I have to be in radians. Bottom line, guys, I need your help right now. What is this angle measure? All right, what is that angle measure when the hour hand's on 12 and the hour hand on 2 and the minute hand on 12? There's the hint I gave you in your homework that night, but I won't be giving you the hint tomorrow. It will not be provided that 1 minute, every time that either the hour or the minute hand goes in 1 minute, it's going 6 degrees on the clock. Every time it goes a minute. Well, how many minutes am I going here, guys? From 12 to 2, how many minutes am I going? 10 minutes, right? 10 minutes. This whole space here represents 10 minutes. So I say, all right, 10 minutes. I would take 6 times 10 now. So that's a 60-degree angle. All right, 60 degrees. So now you have a choice. You can go right to the degree formula and say, hey, 60 degrees over 360 times pi, diameter was 8. And maybe the directions say leave your answer in terms of pi, then you put pi in your answer. Maybe it'll say nearest 10th, nearest 100th, and I type that whole sucker in my calculator. If you want to use theta equals S over R, you do need to take 60 degrees and convert it into radians so you can plug it in for theta. That's if you wanted to use theta equals S over R. All right. And then whatever that came out to be. The biggest thing on this clock question is, what is the angle being formed? Okay, because that is your big missing piece to plug into the formula. What is the, whether it's 2 o'clock, 3 o'clock, 4 o'clock, 10 o'clock, whatever the angle being formed is the major piece to this. All right, where else do we go in here? Let's keep this rolling. Good first question.
Can we go over doing degrees to radians or radians to degrees?
Sure.
I was having trouble solving them, if that makes sense.
Sure. All right, let me start. Let me just keep on this problem right here. I had this 60-degree angle. I wanted to use theta equals S over R, but I need it in radians. So I go to my conversion sheet, which I'll give you guys tomorrow. And it says if you're going from degrees to radians, you want to multiply by pi over 180. All right, they'll be right there on the formula sheet. Now, anytime you're going to leave your answer in radians, you want to leave it in terms of pi instead of a long decimal on your calculator. So leave it in terms of pi. And now all you have to figure out is what is 60 over 180 reduced as a fraction. And you can just plug that right into your calculator. 60 over 180 into your fraction template, enter. It'll say it's 1/3. So 60 degrees is pi over 3. And that, in this problem, is what I would plug in for theta if I wanted to use that formula to solve this clock problem. Okay, so I multiply by pi over 180 if I want to go to radians. If I want to go to degrees, let's say I have 3 pi over 4 radians. And for whatever reason tomorrow, you really needed it in degrees. Now, remember, I'm not going to ask you guys to convert anything for me tomorrow. If you're going to convert, it's for your own convenience because you remembered a certain formula. So let's say I wanted to turn this into degrees now. Now I look on my formula sheet where it says radians equals degrees. It's going to say to multiply by 180 over pi. All right, 3 pi over 4 times 180 over pi. The pi's do cancel because one's on the bottom, one's on the top. Now, I just multiply my numerators, 3 times 180, and divide it by 4. I think that comes out to be 135 degrees. And again, guys, I'm not going to ask you to do this on a single question. The only time you're going to need to convert is because you are using a certain formula for arc length and you need it in degrees or radians and you have the opposite. Whew. Good questions here. Where else are we going? Again, formulas for tomorrow. Circumference, arc length formulas. Circumference and arc length formulas you'll need. Let's go over right now, too, before somebody asks another question. Theorems that we'll probably need tomorrow. There is a proof on here. Theorems. There's the center. Okay, let's start here. If the arcs are congruent, if I know the arcs are congruent, I now know the chords are congruent to each other. All right, there's one fact. Congruent arcs imply congruent chords. All right, let's keep going. Let me keep the arcs congruent. If the arcs are congruent, so are the central angles, remember. All right, same thing. Congruent arcs imply congruent. And yes, hey, I'm going to be picky here. If you just put congruent arcs imply congruent angles, that's garbage. All right, that's garbage. That's not what the theorem says. And you're not saying just plain angles are equal. You're saying central angles. So put that word there. Congruent arcs imply congruent central angles. All right. Let me get rid of this. Let me draw this in. A little piece of a radii perpendicular to the chord. What do you know? If you got a radii perpendicular to a chord, what's happening to that chord? Anybody?
It's getting bisected?
The chord is getting bisected, correct. The chord is getting bisected. All right. Let me keep going and adding on some pieces here. Let's say I know the chords are congruent. Both chords here are congruent. That means they're equal distant away from the center. Two chords that are congruent are equidistant away from the center, so I would know both these pieces are equal. A lot of theorems there from our fourth day. All right, a lot of theorems.
What's the theorem that with the inscribed angles, if it opens to the like same arc, then the angles are congruent or something?
Two inscribed angles drawn to the same arc are congruent. So if you have no, that's not what I wanted. Sorry. So I'll just take two you can focus on, angle A and angle B. They're both inscribed angles. And notice how they're both drawn to the same arc, CD. Okay, so that would mean automatically both A and B have to be congruent. because they're inscribed angles drawn to the same arc. I would not have you guys use that in a proof. There's no inscribed angle theorems in the proof. All the proof theorems come from day 4. But hey, yeah, you could answer an algebra question on inscribed angles using this theorem, yes, but not in a proof yet. We're not ready for that yet. And also, while we're on the topic of inscribed angles, if I have a quadrilateral inscribed, what do we know? If the quadrilateral is inscribed, what's the theorem say? Ooh. Oh.
Their opposite angles are supplementary?
Opposite angles are supplementary. Yes. Yes. Opposite angles are supplementary. Okay. A lot of theorems here. A lot of facts that you may need. I know. But that's why this unit's as tough as it is. Whew. Others you'd like to go over?
Can you go over one of the problems on the circle sheets on the classroom?
You got it. Which one?
The inscribed quadrilaterals one, number 6.
Got it. Inscribed quadrilaterals. Here it is. Open up. Ooh, all right. Good one. All right, so here we go. First one, determine and state the measure of G arc GFE. All right, so G to F to E right here. Well, they give me that angle D is 86. Angle D is inscribed. And if I take a look at the arc that it forms, look at what it conveniently forms. The arc I'm trying to find the measure of right now, doesn't it? Angle D is drawn to arc GFE. And I know that angle D was found by taking half of GFE. So I'm going to go in reverse and say arc GFE has to be double 86. 172 degrees. All right. Again, D was the inscribed angle drawn to the arc you asked me to find. And then finally, angle F. This was good timing bringing this question up because this was the theorem I just started talking about. I have a quadrilateral inscribed in a circle. Opposite angles are supplementary. D and F are a pair of opposite angles in that quadrilateral. So they are supplementary. So 180 minus 86 will give me angle F. And 94. All right, so that theorem being applied right here in this problem. Other questions? Come on, there's got to be more. I kind of went over everything. I wanted to make sure I hit on all the theorems. How about this? And, I always like to make sure I treat I want to make sure I treat both groups the same. Proof? How about a proof? Try out a proof to show you exactly the type I'm talking about. We did one yesterday, so I want to make sure I stay fair to you guys too and do one with you guys. All right, very basic proof here. I'm showing you up on the screen. Prove A congruent to C. The only way I'm going to do that is to prove the triangle's congruent. Because A and C are not inscribed. By the way, anybody, for a little challenge bonus here for me, anybody know why A and C are not inscribed even though A and C are on the circle?
Because they're central angles?
Not A and C aren't central because a central angle would be angle Q. Remember, inscribed angle, the vertex is on the circle, but these aren't inscribed. Anybody know why?
Are they radii?
Yeah, well, QA and QC are radii. They both have to be chords, remember. All right, they both have to be chords. So that's why they're not inscribed. All right, so you guys want to help me prove the triangle's congruent here? I am given that B is the midpoint of arc AC. All right, you guys want to chime in and help me out from there? You can take that first given and tell me what's true then. If B's the midpoint of arc AC, what do you got for me? Come on there, ladies, gentlemen.
AB is congruent to BC.
Good. Arc AB, right? Because there's a lot of ABs going on there. You could have been talking about a chord or the arc. So make sure arc AB is congruent to arc BC. Yep. Definition of a midpoint. All right. So I got the two arcs congruent. All right. Ooh, you got a lot. Here come the theorems now. Here come the theorems. What do you got for me? See any other congruent pairs of parts up there?
Their chords are congruent.
Okay, we can go ahead. I'm listening, sir. AB and C, BC. Why?
Because congruent arcs they imply congruent chords.
Good. Congruent arcs, which I just wrote down in step 2, mean their chords are congruent. Perfect. All right. There's a pair of sides in the triangle. There's one pair of sides. Okay, others you see? Anybody else? Others? It's got to be something else we see, right?
If arc AB and arc BC are congruent, does that mean AQB and CQB are congruent?
The central angles are, absolutely, yep. So angle AQB congruent to CQB. And here you go, congruent arcs imply congruent, and this is what I was talking about earlier. Do not just put congruent angles. Be specific. Congruent central angles. All right, good. So now you guys have a pair of angles there and a pair of sides. Let's keep going.
I don't know. I probably would have not proved the chords, if that makes sense, and then done radii and then reflexive to
Yep.
angle,
Mhm.
side angle side.
Yep.
I don't know what to do to have an actual triangle proof, if that makes sense.
I don't know what you
Because there's no SAA, so
correct. Oh yes. Okay, I see where we're going. If you guys right now just said, "Hey, Mr. Carlino, QA is congruent to QC because all radii in a circle are congruent," you would not have enough information to prove those triangles congruent right now because, as Sarah said, there's no sides SSA. Never will be either. All right. You would need to go through, and I'm going to keep going here. I'll put that down. QA congruent to QC in a circle. I can't, gotta have that little statement there. In a circle, all radii are congruent. If you do not have in a circle and just write all radii are congruent, that's a false statement. Not every single radii known to man are congruent to each other. Absolutely not. But now if you stopped your proof here and said the triangle's congruent, you're wrong because there's no side-side angle. You are going to have to go now. Oh, all right, here I go. QB congruent to itself. Reflexive. And now at this point, you can say side angle side, 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 and then end up with CPCTC. Okay? So that's what you can end up with. Yes, Peter.
If it is possible, can you prove the two triangles are similar to prove the two angles are congruent?
To prove them similar, what would be your method to prove them similar?
I'm just asking if it is possible.
It is, if you can say two triangles, no, that's not true. If you say two triangles are congruent, then you could say they're similar. But you can't say all similar triangles are congruent. You could say congruent triangles imply similar triangles. Yes, that is true, but the opposite is not true. And then just remember, guys, you'd have to prove, I won't write it, but you got to prove the triangle's congruent by a method and then CPCTC to get angle A congruent to angle C. Other questions, comments here? Still got some time left.
Can you go over the arc length equation, kind of just how to go through it that isn't the one in radians?
Yep. Okay, so you want the one in degrees. Is what I'm
Yeah, where
hearing.
you put it over 360.
Yep. Okay, so you have, and I'll draw a circle too so we could see it visually. Length of an arc equals measure of arc over 360 times the circumference, pi d. All right, so I have my circle. The measure, let me put a couple letters here. A, O, B, I'll put C over here. All right, so let's say I asked you to find the length of AB. The length of AB, this length right here. There's the length of AB I'm asking for. So first thing you need to know is what's the measure of AB in degrees? And you could get that two ways. Maybe I just come right out and say, hey, the measure is 50 degrees. Or remember, the measure is also the same as the central angle. So maybe I tell you this is 50 degrees instead, and you go, oh, if the central angle is 50, the arc measure is 50. Times pi. Now you got to figure out what the diameter is. Maybe I give you radius and you double it. Maybe I do give you the full diameter. All right, but that is how that formula works. And just keep in mind, the only thing I'm giving you guys is a reference sheet tomorrow, which has the radians and degrees conversions. That's it. So this formula up here will not be given to you.
So what if there's a number in the place of the L or the length?
Okay, yep, sure. So we're saying we know the length, and let's say, I know it's 3.5 units. Let's say we're trying to find the measure of the arc, so I'll put an X there, over 360 times pi. You figure out the diameter 6. All right, now I got to figure out what X is. It's really your preference here. You could get rid of the 360 first by multiplying both sides by 360. And when you do that, realize that all you're doing is canceling out the 360. There's no distribution or anything. It's all multiplication inside here. Inside here, it's all multiplication. So you're just getting rid of the 360s, and that's it. Then you would have X times pi times 6 equals whatever the heck that is. I have no idea. All right, so whatever that is. And now it's up to you. Do you divide by 6 first? Do you divide by pi? Or if you want to, you can divide by everything. So divide by 6 pi. But I would just warn you, when you go to your calculator and divide by pi and a number at the same time, put that bad boy in parentheses. Okay, put that bad boy in parentheses. But again, you can divide by 6 by itself and then divide by pi. Or if you decide to do both of them at the same time, just make sure you put it in parentheses. Anything else, guys? Anything else? Okay, then you guys always know if something does come up between now and tonight, email me. I'll get to you as soon as I can when I get home tonight. All right. If not, I'll see you guys in class tomorrow. Some of you, if not, good luck on the formative tomorrow. Okay. Yep. Have a good night, guys. Behave. See you guys later. Take care.
Can you just go law of cosine?
Sure. So you have a triangle. You know 2 sides and the angle in between, and you're trying to find the third side. So now you start with, you always have to start on the left-hand side, you always have to start out with the side across from the angle, which in this case would be x squared equals the other 2 sides squared minus 2 times those 2 sides times the cosine of the angle, which would be 30 here. And then you should be able to plug all of this into your calculator at once. But
Okay.
you need 2 sides and the angle in between to use law of cosines.
Okay, thank you.
Yep, you're welcome.
Bye.
Bye-bye. Have a good night.